Hi everybody, it's Tom Cherams with the FujiNet project. And I wanted to take a few minutes to address the developers in the audience about application keys, or app keys, and how they can be used in your FujiNet programs for the Coleco Atom. Application keys basically allow you to store information separate from your network program, which may be loaded over the network, and to be able to store them onto the local storage of your FujiNet via the SD card slot. Common uses for app keys include authentication credentials and preferences storage, but it can be used for anything you wish. To start with here, we'll take and do a little demonstration of app key functionality here by flicking on my atom here. And we'll see that we've loaded an app key test program right here. You can see that app keys are basically made up of 3 separate fields and a data field. That is, there is a creator ID. This is a 16-bit ID, which means that there are 65,536 possible creators. Then there is the application. Each creator can have an application, and this is an 8-bit field, so up to 256 applications per creator. And each application has an 8-bit field called key, which allows up to 256 stored preferences per application. We hope that this is sufficient, and if it's not, please let us know. But using it is simple enough. All we have to do, right now we can see that, apologies here. We can see right here that we have an app key stored here of blah. We'll take and put something else in here, and it's stored, and it read it back again. It's reading that off of the SD card each time, and if I take and reset and reload the program, you'll see that the value gets read again. And this value is not being stored over the network, but is actually being stored locally on your FujiNet. And in fact, if we actually take and remove the SD card for a moment here, I'm going to remove the SD card from my slot, and I'm going to put it into my little SD card holder and pop it into my machine so you can see what actually is being stored here. Give it a few moments to open up the file manager. And we can see right here that we have a FujiNet folder. If this folder does not exist on your SD card, it will be created automatically. And inside of it, we have a number of key files, which reference the creator ID, the app ID, and the key. And if we open up the file itself, we can see our value literally being stored inside of there. Simple enough, I think, but you can see very effective. We'll go ahead and eject that, put that back in my FujiNet, but now we'll actually talk a little bit about the test program, and how this is actually working. This is implemented like every other call to the FujiNet device, which the Fuji device essentially controls all of the control functions on FujiNet, such as mounting and unmounting devices and other bits of global state, and that includes dealing with app keys. There are 2 commands that have been added to implement app key reading and writing, DD and DE. These are the first byte of the send packet that you send back. And you also need to send back, in addition, each one of these, you need to send back a 16-bit value, which is the creator ID, an 8-bit value, which is the app ID, and an 8-bit value, which is the key ID, in that order. And in fact, if you're using a language like C, you can use something like a structure to take and make sure that all of this gets put in the correct order, so you can just send it out using the EOS write character device calls or similar. It's pretty simple. All of this is being done using standard EOS calls in every case. As you can see right here, the amount of data that you can store per key is 64 characters. If you need more, you have another key, and you can use them however you see fit. But we think that 64 characters is rather sufficient here in terms of data transfer efficiency. Again, if there's an issue with this, please let us know. It's pretty simple. All you have to do is send the command. If you want to read an app key, just send the above structure into write character device and read back the result. Conversely, with write, it's exactly the same data structure. You just write the value that you want to write, and the FoodUnit will take care of writing the application key and creating everything that it needs to create. So in the end, when you wrap those up into two nice little functions, you get app key read and app key write, which are very easy front ends to take and deal with this. You can do this in any language you like, Pascal, Basic, whatever. It doesn't matter because you're essentially using EOS or using the AtomNet controls directly. So with that, I hope this has been an effective demonstration. I have a few other videos in the pipeline here as things kind of wind up for the Atom version of the FujiNet. But if you guys have any questions, please let me know, and I will try to answer them. So until next time, guys, have fun.